Humanity is finally building the hardware required to cross the solar system and colonize the Martian surface. But our ambition currently outpaces our biology. The reality of deep space is an environment engineered to kill human tissue. Looking at this 3D model, you can see how Earth's magnetosphere shields us. Once a spacecraft leaves that protective bubble, it is immediately subjected to invisible, high-velocity threats, specifically galactic cosmic rays and sudden, violent solar storms. Launching a crew directly to Mars today would likely result in their deaths long before they reached the Martian surface. NASA is establishing a $20 billion permanent lunar surface base under the Artemis program to serve as a mandatory proving ground for these problems. The mission builds the precise survival architecture required to keep a crew alive during the multi-year transit to Mars. For the last 20 years, astronauts aboard the International Space Station have lived safely within the protective shield of Earth's low orbit. Artemis 2 will push humans further into the unprotected void than any previous mission. To figure out how to survive that deep space radiation, NASA faced a biological dilemma: how to test these lethal effects without actively endangering the lives of the crew. Scientists developed a workaround called AVATAR, a virtual astronaut tissue analog response. Doctors drew blood from the actual Artemis 2 crew members to grow personalized living bone marrow cells for each specific astronaut. Living cells are loaded into USB-sized tissue chips, where microchannels pump nutrients so they function like miniature organs. Inside the capsule, they absorb the exact same barrage of cosmic rays, allowing researchers to observe DNA breaks at the molecular level. Back on Earth, that biological data will allow doctors to formulate personalized medical kits and radiation countermeasures tailored strictly to the genetic makeup of individual astronauts. Mapping cellular radiation damage during a lunar flyby is the only way to guarantee a crew's biological survival during a multi-year Mars transit. Operational hurdles are just as severe as the biological ones. NASA relies on the massive satellite dishes of the Deep Space Network to maintain the data and communication umbilical cord between Earth and its spacecraft. This map of the inner solar system highlights a hard physical limit: the speed of light. A single message sent to Mars takes between 4 to 24 minutes to arrive. This delay makes real-time problem-solving and emergency support from mission control physically impossible. The lunar environment experiences a highly manageable 1.3-second communication delay. At the 20 billion lunar base, crews utilize this safety net to practice total operational autonomy, running life support diagnostics, executing emergency protocols, operating entirely without Earth's help. Mastering this absolute self-reliance 240,000 miles away is the mandatory prerequisite before attempting it 140 million miles away. The cellular data harvested from AVATAR and the autonomous operations perfected on the lunar base interlock. These Artemis milestones are actively forging the tools and writing the practical survival manual for the next frontier. The path forward leads humanity through a violent, fiery atmospheric entry, descending toward the red surface of Mars. After months of profound silence and isolation, an outpost finally takes shape on a new world. The generation that learns to survive on the Moon today is the generation that will thrive on Mars tomorrow.